Right. So I'm starting now. This is the first class of algorithm subject. Right. This is the first class. So I written the algorithm also. Right. So the book which you can refer at any point of time, if you have doubt, you can refer this book. Reference book. Introduction to Algorithm by Coreman. Introduction to Algorithms by Coreman. Recent edition you can go. I think maybe 4th edition or 5th edition, I don't know. Recent edition you can go. So this is the book which you can refer, right, to this subject purpose at any point of time if you have doubt, right? So you can refer this book, Introduction to Algorithm by Coreman. Recent edition you can. Recent edition you can go ahead. Right. Hi. Yeah. Good evening. Good evening, everyone. Good evening, everyone. So I hope everything is fine. So this is the book which you can refer. Yeah. Come to the next one. Read syllabus. To the subject syllabus. Algorithm subject syllabus is going to be first one. Analyzing algorithm means finding time complexity. First one is analyzing algorithm. Analyzing algorithms. That is the first chapter. Analyzing algorithm, that is the first chapter where you will find out time complexity, space complexity. That is the first chapter. You will find out time complexity and space complexity. That is the first chapter. So second chapter is going to be recurrence relation. Recursion and recurrence relations. That is the second chapter. Recursion and recurrence relations. That is the second chapter. Third one is recurrence relation solving. That will be the next chapter. Fourth chapter, asymptotic notation. Where we will find out, where we will discuss about big O, omega, and theta. So fourth chapter is asymptotic notation. Right? First, analyzing algorithms, time complexity, space complexity finding. Next one is recursion, recurrence relation. Next one, recurrence relation solving. Right? Fourth one, asymptotic notation. Right? Next one, fifth one, divide and conquer. Where you will see in the divide and conquer, you will see finding maximum minimum, finding maximum and minimum. Divide and conquer, in the first one is finding maximum minimum. Second one, power of an element. Third one, binary search. Please write the topics first. So fourth one, merge sort. Fifth one, quick sort. Sixth one, counting number of inversions. So sixth one over. Seventh one, maximum subarray finding. Maximum subarray. Maximum continuous subarray sum. Continuous subarray sum. So eighth one, Strassen, I think selection procedure. Selection procedure. Ninth one, Strassen's matrix multiplication. Strassen's matrix multiplication. So this is the divide and conquer story. This is the divide and conquer story. Please write all of them. This is the syllabus. First, analyzing algorithm. Second one is recursion, recurrence relation. Third one is recurrence relation solving. Fourth one is asymptotic notation. Fifth one is divide and conquer. In that first one, finding maximum minimum, power of an element, binary search, merge sort, quick sort, counting number of inversions, maximum continuous subarray sum, selection procedure, Strassen's matrix multiplication. So these are the topics in the divide and conquer chapter. So next one, sixth one, greedy technique. Greedy technique. In the greedy technique, first one. In the greedy technique, first one, knapsack problem. Knapsack problem. First problem is a knapsack problem. Second one, job sequencing with deadline. Job sequencing with deadline. With deadlines. Third one, Huffman coding. Huffman coding, third one. Fourth one, optimal merge pattern. Optimal merge pattern. So fifth one, minimum cost spanning tree. Minimum cost spanning tree. Sixth one, right? Fifth one is minimum cost spanning tree. Sixth one, shortest path, single source shortest path. This is the sixth one, greedy technique, knapsack problem, job sequencing with the deadline, Huffman coding, optimal merge pattern, minimum cost spanning tree, single source shortest path. These are the 6 techniques. 4 plus 2, yeah, 6 techniques. Go to the next one, seventh one, dynamic programming. Dynamic programming. In that first one, Fibonacci series. Second one, longest common subsequence. Longest common subsequence, which is also called as LCS. Third one, matrix chain multiplication. Matrix chain multiplication. Fourth one, longest common subsequence. Third one is matrix chain multiplication. Fourth one, 0 by 1 knapsack. So fifth one, sum of subsets problem. Sum of subsets problem. Sixth one, all pair shortest path. All pair shortest path. Seventh one, optimal cost binary search tree. Optimal cost binary search tree. Thank you, Robit Kumar. Thank you so much. So these are the syllabus, right? Please write everything. Please write everything. My request to everyone, please write everything. Please write everything. You have to make your own notes. You have to make your own notes. My sincere request to everyone, make your own notes. Don't ask, sir, can you give the notes and all? Don't ask. Don't ask, sir, can you give the notes and all? Don't ask. And today's date I am writing. I am writing the today's date also. I think today's date, if you see, I think 06/11/2024. This is the date. Right? Syllabus is started. Write the nice notes. Notes is nice. Right? You will get more interest of reading. Notes is nice. You will get the more interest of reading. You will get the more interest. It is the first chapter. Analyzing algorithm. It is a common topic for the algorithm subject. Everywhere the story will come. Time complexity finding, space complexity finding, everywhere it will come. You have to make nice notes. This will be useful forever in your life. You joined the job also, it will helpful. You went to the higher studies, then also helpful. Everywhere it is useful. Everywhere. I will cover A to Z. I will cover A to Z. I will cover A to Z. In the divide and conquer. These are the topics. In the divide and conquer, these are the topics. Finding maximum, minimum, power of an element, binary search, merge sort, quick sort, counting number of inversions, maximum continuous subarray sum, selection procedure, Strachan's matrix multiplication, greedy technique. In the greedy technique, knapsack problem, job sequencing with deadline, Huffman coding, optimal merge pattern, minimum cost spanning tree, single source shortest path. Next one, dynamic programming. Fibonacci series, longest common subsequence, matrix chain multiplication, 0 by 1 knapsack, sum of subsets problem, all pairs shortest path, optimal cost binary search tree. So let's have clarity. Anything you have doubt, let me know. Anything you have doubt. Totally almost like 7 topics. Totally 7 topics. If you okay, I can move to the next story. Just to follow whatever I am saying, just to follow. Whatever I am saying, just to follow. If you okay, please type in the comment section okay, so that I can proceed to the next story. If you okay, please type in the comment section okay. Please type in the comment section okay, then I can proceed to the next story. Everywhere, this is the fundamental one. In the computer science, if you want to survive, this subject is major. You want to do something in the computer science, this subject compulsory. Algorithm followed by data structure compulsory. It is a compulsory. It is a compulsory. Please learn properly. Don't by heart. If you are more good, you will get the better job. If you are okay, then you will get okay job. If you are little bit, then you will get a small job. You know algorithm and data structure little bit. You will get a very little bit job. Small job you will get. If you are average in that, right, data structures and algorithm, you are average in the DSA, you will get the average job. You are extraordinary in the DSA, you will get the extraordinary job, maybe 5 lakh per month job. Please remember how much strong you are in this subject, right? That kind of job you are going to get. How much strong you are in this subject, that kind of job you are going to get. You may say that, sir, I don't know algorithm. I also don't know. I also studied. I also learn. Every day I learn little bit. Sir, I am completely zero, sir, in algorithm. I also zero. Few years back, I also zero in algorithm. I also studied. My students also studied. There are some students who don't know anything about algorithm. But finally they became so good. Yashwant is asking something. Yeah, Yashwant. Yashwant, yes. Check properly. Everything, please study everything, whatever I am saying. Everything, whatever I am saying, please study one time. It's a more than enough. It's a more than enough. One time study. Right. And one more thing, my sincere request to everyone. One more thing. If you little bit sleepy also, assume that you are watching this lecture, you are little bit sleepy. If you are little bit sleepy, you slap yourself like this. Everything okay. Are you sleepy? You slap yourself like this. Do 5 times like this, everything is all right. If you are sleepy, just slap yourself. If anyone is little bit sleepy also, I'm going to start this subject now. If you are little bit sleepy also, please slap yourself. Take one glass of water, throw on your face. Otherwise, go to your bhaiya, slap your bhaiya. He will slap you double. You slap your bhaiya like this. Your bhaiya will slap you double. Then automatically your sleep will go. Beat your behan. Beat your sister. She will beat you once again. Then everything is okay. My sincere request is, if you little bit sleepy also, please can you control? Little bit sleepy also, can you control? Yeah. Now come to the next story. I think everything is fine. Write the definition for algorithm. Algorithm definition, right? I'm starting now. Algorithm definition, I'm writing. Definition. Algorithm definition. It is a combination of. It is a combination of sequence of finite steps. It is a combination of sequence of finite steps to solve a problem. It is the definition. See, I started with the definition. Everyone will get. I never seen a person who don't, right? I never seen a person, he attended my lecture of algorithms and he didn't get algorithm. I never seen a person. If you don't know algorithm, you will also get. Every student of mine got algorithm subject. You will also get. Definition onwards I started. With the definition. It is a combination of sequence of finite step to solve a problem. It is a combination of sequence of finite steps to solve a problem. That is the definition. Now, some people are asking, sir, what it means? Can you give an example? Let's take one example. Let's take one example. Sir, can you give one example? Yeah, I'm giving. You can write any program, whatever programming language you want, you can write. Just I'm writing pseudo code kind of thing. I'm writing pseudo code kind of thing. See this one. Addition of two numbers. Addition of two numbers. I want to add two numbers. Addition of two numbers. I want to add. See the algorithm. Addition of two numbers. I want to write algorithm. I'm writing first step. First step. Take two numbers. Take two numbers. Assume they are A comma B. Right? If you want to add two numbers, see, adding two numbers, I am writing algorithm. Adding two numbers, I am writing algorithm. See, addition of two numbers, I am writing algorithm. First step, take two numbers. Assume they are A comma B. Take two numbers, right? Okay, I done. Next one. Can you see this one? 2. Add both A and B. Add both A and B. Store in C. Add both A and B. Store in C. That is the second step. You want to add two numbers. First step is take two numbers which you want to add and add both of them, both A and B, store in C. Third step. If you want to print that C, you can print. If you want to return that C, you can return. Print C. Print C value. Print C value. So end of the algorithm. This is the algorithm. Addition of two numbers. Yeah, of course. Abhinav, everyone will get. I seen many people. They don't know anything. Still they will get. I will take care. It doesn't matter what is your background. If you are determined, you will get. If you determined, you will get. It doesn't matter what is your background. You are studying BTech means, right? You will get it. Are you studying BTech? Or are you studying bachelor's degree? Easily you will get it. Right? So some people are asking, sir, what is the algorithm definition? See, I written the definition. Now, sir, can you give one example? I give an answer. Now I will explain. Why it is an algorithm, I will explain. It is the definition. So remember, algorithm subject started here. I am writing the boundary also. Actual algorithm subject started here. If anyone came late, don't worry. From here you can follow. Algorithm subject started from here. Right? So algorithm, it is a combination of sequence of finite steps to solve a problem. So definition I written. Some people are asking, sir, can you give one example? I written the example also. Sir, I didn't get the example. You will get. I will explain. Don't worry. You will get. Don't worry at all. And one important thing, if you have any doubt, post in the comment section. If you have any doubt, post in the comment section. I'm there here to help you. Little doubt also there. Post in the comment section. It is a combination of sequence of finite steps to solve a problem. Right? So I written the program also. Now understand. Everyone try to understand. This algorithm contain how many steps? Remember, every line is one step. So see this one. Right? If I want to say in another way, some work is there. Little bit work there. Make it as one statement. So this is the first step. Some work. It is also some work. Every work is nothing but one step. So in this algorithm, if you observe clearly, finite steps are there. So remember, algorithm means finite steps. Whenever you say it is an algorithm, finite steps should be there. This algorithm contains 3 steps. 3 is a finite number. So every time remember, algorithm means finite steps should be there. That may be 3 steps. that may be 30 steps, that may be 300 steps, that may be 3 lakh steps. Algorithm means finite number of steps needed. Every work is nothing but one step. If you think that some work is there, oh, some task. Work is nothing but some task. Oh, is it some task? Taking two numbers is a task. Yes. Some work is there. So one step. Adding both of them, storing in C. It is also one task. Yes. So that is also one step. That is also one step. Next one. Printing a number. Is it also some work? Yes. Without printing, how can you see the result? So that is also one task, which is nothing but one step. So remember, algorithm means finite steps needed. If anyone asks you from today onwards, I given something to you, is it an algorithm or not? First condition you have to verify. First condition you have to verify. Finite steps are there or not there? Check. Is it algorithm? First step. Finite steps are there? Yes. Finite steps are there? Yes. Yeah, it is algorithm. Every algorithm should have finite steps. Okay, finite steps are there. That is also okay. Next one. It is a combination of sequence of finite steps. Remember? See, remember everyone. Remember everyone. If you think second one is not required, then why you return? If you think that first one is not required, then why you return? If you think that third one is not required, then why you return? So remember, algorithm means combination of all these three required. If I feel something is not required, I don't write. It is a combination of all three compulsory. It is a combination of, and one more. What about sequence? So after 1, 2 will come. Without taking two number, how can we add them? Next one. Without getting the result, how can you print them? Right? Order also important. When you say it is algorithm, right? Finite steps should be there. When you say it is algorithm, combination of. If you think that second one is not required, then why you return? It's a combination of sequence of. See, sequence. First one will execute. After 1, 2 will execute. After 2, 3 will execute. Right? Mostly order is there. Without taking number, how can I add? Without getting the result, how can I print? So this is the order. From today onwards, if anyone say what is the algorithm definition, simply say it is a combination of sequence of finite number of steps to solve a problem. Finally, it should solve your problem. Finally, it should solve your problem. Suppose problem is not solving, there is no point of writing algorithm. Suppose someone will say that I written algorithm, it is not solving anything, then why you written? Algorithm should solve the problem. What is our problem here? Printing, right? Adding two numbers. What is your problem? Adding two numbers. Is it doing adding two numbers? Yes. Finally, it should solve the problem. Algorithm